Now let us move to discovery of radioactivity, discovered by Henry Becquerel. Why we use this here? Because this discovery helped Rutherford to understand atom to a further extent. So this is like how Michael Faraday's CRT used by J.J. Thomson. Similarly, this discovery helped Rutherford to understand his model. So that's how the atomic model improved. Now let us see what we are going to understand here. We are not going to understand in detail. We are going to understand three different radiations emitted by various radioactive elements. So we know that radioactive elements are kept in lead chamber, because lead chamber won't allow, or lead won't allow radiations to propagate in all the direction. Wherever we kept open, radiation only travel in that direction, and just against that detector was kept, and detector is also coated with fluorescent material, so show some glow in this direction, so we can understand that. So he studied the behavior of this radiation. So he subjected this various radiations to, in the presence of electric field. We know electric field contains positive and negative terminals. They are connected to a battery, that's why. So there were some radioactive elements, when they ejected radiations, they went undeflected. They neither deflect towards positive nor towards negative, indicates that they are not at all charged radiations. So that's why they were later named as gamma rays. So have no charge. I later understood that they do not have mass also. So gamma rays are represented like this: no charge, no mass. Literally they have no mass. But when other radiations were also understood, for example, there are some radioactive elements, they ejected radiation. That ejected radiation deflected towards positive terminal, indicating that they are negatively charged, called as beta particle. Now why they are called as particle? Because they have some mass in it, but in the case of beta, their mass is negligible. That's why it is considered zero. It doesn't mean that their mass is zero, which is very, very less. In this case, literally there is no mass. That's why we later are going to understand gamma rays as electromagnetic wave. So in this case, beta particles have mass. So then there were some radioactive elements, they ejected radiation that deflected towards negative terminal. So definitely we can understand that they are positively charged. Later called them as alpha particles. Alpha particles. And later understood that alpha particles nothing but 2 protons and 2 neutrons are collectively coming out of radioactive elements. So when I say 2 protons, that definitely they must have 2 positive charge, because neutrons have no mass, no charge. And but mass wise we can have to count both. So 2 protons have 2 AMU mass, 2 neutrons have 2 AMU mass, so collectively 4 AMU mass. So this is how he understood 3 different radiations coming out of different radioactive elements. So what we have to use here is, we have to just know that there are 3 different radiations, they are charged in different way like this. Now size wise, if you understand, this is of biggest size out of these 3, because having bigger mass, and that of smallest size we can say, I mean almost no size, because it is not having no mass. So size wise we can understand alpha is bigger size and that of beta, and thereby gamma. For comparative purpose we are doing this, otherwise gamma is not a particle, it's a wave. So when I talk about size, now what happens, if you want to understand their penetrating power, For example, if I consider a thin sheet, a thin paper sheet. Now we know paper sheet also made up of many molecules like cellulose and stuff. So these molecules of that paper definitely coiled like this and will be having some intermolecular spaces. Definitely each and everything will be having intermolecular spaces, but that space will vary from substance to substance. That some substance will be having bigger space, empty space, and some substance will be having smaller. And if you use this sheet multiple sheets, then what happens, that particular space will now get reduced further. Why? Because there are this, maybe it is having some space here and one more sheet is having hiding this particular area, so that is possible. So what I'm making you to understand here is, any material if I talk about, then definitely it will be having intermolecular spaces. Now being smallest size here, gamma rays almost penetrate through almost each and every particle. Depending on thickness of the substance, definitely you can resist the propagation or penetration. In this case, as I told you, lead almost stops the propagation of various radiations, because the thicker one if you use, if the thinner one if you use, even lead cannot withhold that particular radiations. Now if I compare out of these three, gamma is highly penetrative because of its smaller size. Even it needs very small size to pass through, and that very small size is almost present in all materials. Definitely when you increase the thickness, that the size will further decreases. As thickness increases, penetration will decrease. But out of them, if I consider here penetrating power, if I compare, alpha has least penetrating power and gamma has highest. Why? Because size wise, this is the smallest size, it can pass through many material. That of alpha being bigger in size, it needs bigger empty space to pass through. And the reverse is ionizing power. Why I am saying reverse? Ionizing power, because when these radiation hit any material, let us say if it is hitting this material, if this material is not allowing that radiation to pass through, then what happens, there will be a fight in between, there will be a collision in between them. So this collision will end up with destroying this area, because if this particular material is continuously stopping other radiation to pass through, then there will be a fight in between, thereby whatever resisting that may destroy, depending on how energetic the radiation is. So one which is allowed to pass through, it won't ionize the material because it has simply passed through that. And the radiation which was not allowed to pass through, then it will start ionizing that material. That means in terms of ionizing power, alpha has highest ionizing power, followed by beta and gamma. Because alpha was not allowed to pass through, then it will simply ionize the material. Next is the speed that we have to remember here. Speed wise, we know that heavier material, heavier particles travel with less speed as compared to massless material. So speed wise, we can say alpha is having less speed of propagation, and that of gamma is having highest. Gamma speed is, if you roughly measure, that is same as that of other electromagnetic radiation, that is 3 into 10⁸ meter per second. That of beta is 9/10 of this speed. This is the speed of light. That of alpha is 1/10 of speed. Roughly we can compare in this way. So alpha